Hey everybody, this is Larry. It is May 3rd of 2023. And I'm going to try to do an actual problem that isn't an SQL problem for today, if you saw what I was trying to do earlier. Oh man, alright, let's just do another RNG one. Um, I mean, I'm happy to do, but maybe today I'll just try to do another thing first. Alright, today's extra Larry problem is 1810. Minimum path cost in a hidden grid. Okay, let's see. This is an interactive problem. There's a robot, N by N grid. Each cell is either empty or blocked. The starting cell and the target cell are different and neither are blocked. Each cell has a cost you have to pay when you move the cell. The starting cost is not applied before the robot moves. You want to find the minimum cost to move the robot to the target cell. However, you do not know the grid's dimension, the starting cell, nor the target cell. You're only allowed to ask queries to the grid master object. That seems fun and interesting. We'll see. Can move in the direction. So okay, so you're just discovering the graph. You move in that direction. Okay. What does it return? Oh, return the cost of moving to that cell. Huh. Kind of funky. Wait a minute. Minimum cost. How do you even get the cost if you only find the cost after moving? Okay, let's take a look. So you don't know anything. What am I trying to do? Okay, so basically, so you're given this thing. You up, down, left. Start at 0, 1. Go left. Okay, so you have to discover the graph. That's kind of maybe fun. So you have to so you have to move a robot to kind of discover the map, and then and then kind of do it. Okay. I mean, I think the idea that I would do is just that first search, right? Yeah, I mean, you have to do a depth first search because you have to move the thing, and yeah, and then you'd use the depth first search to discover the entire graph, and then just one very rudimentary shortest path algorithm. So I'm like getting distracted, Dijkstra or something like this. Not that bad. Kind of maybe funky and interesting. But yeah. And the way that we will, yeah, and we really don't, because we don't know the size or we don't know the initial cell or whatever. We can just for the sake of purpose, we just start at 0, 0 and then just discover the graph that way, right? Yeah. So basically, okay, let's see. How do I want to set this up? So x, y is equal to 0. Maybe can I just write like this, right? And then we use a stack for depth first search, and then we want to push to do xy, right? And then maybe we have a cost thing. Do we know the initial cost of the 3? I guess it doesn't. So yeah. And then now, this is going to be a little bit awkward, but that's fine. But yes, and then while length of stack is greater than 0, right? XY, I guess this is, the way I wrote it is a little bit weird. We just write 0, 0. We just have to discover the graph for now. Is you go to stack.pop, right? And then and then -1, 0. So I guess as long as this is consistent, it should be fine in terms of left, right. I guess this technically, yeah. Right, and then for dx, dy in directions, and maybe I want to zip it with d. Yeah. Maybe I could write this in a little bit better. Maybe I just write something like, I mean, this is a medium, but it's kind of annoying as a medium. Something like this, right? And then now we want to do master dot can move of d. If this we can move there, then we want to push this on the stack. I have to think about how am I doing this. I mean, the flow is basically what I want to do. Is that how I do my first search? Yeah, I don't even know anymore. Maybe D. Right. And then now this is the, I don't know, T for the type maybe. Right. And then at the very end, so here now we do something like master, or if T is not equal to empty, we do master dot move of T. C is equal to the cost, and then cost of XY is equal to C. Right, and then it just does a lot of stuff on the stack. I mean, the stack thing is very confusing. Let me actually, well, the way that I'm writing the stack is a little bit unintuitive, I think. So let me actually redo this using, okay, maybe I'll keep some of it, but I should do it recursively instead, because I am actually getting confused by the way that this is not how I actually do this, so yeah. XY, right? Right? So then now, okay. So for if we can move there, then DFS x plus y plus dy, and by that I mean master dot move d, And then I did like after it pops, I want to do master move opposite D or something, but how do I want to write that? Okay, fine. Of opposite. I don't recommend. I don't know that I recommend doing it this way, but I don't know. I think I want to just get something done, so we'll see how that goes. Okay, so then yeah. Okay, so then on this move, C is equal to this. Cost of move to the south. Okay, so cost of x plus dx, y plus dy is equal to c. I also have to make sure that we don't get into infinite loops. So what do we want to do, right? And x plus dx, y plus dy, not in cost, because I should put this first though. What the heck? Okay, right. Let's see. Oh. Okay. Let's return 10 or something. Oh, okay, 1 is fine too. Let's see. Just want to see if I at least construct the graph correctly. Let's see, right? So 0, 0, we start at 3. We go, what's that? Down is 1. Left is 2. So I think we're good here. And then now, is the second one? Yeah. This looks probably okay. Maybe, I don't know. The numbers kind of match. So now we just have to do a breadth first search on this graph. So I have to check whether it's target, isn't it? Okay, fine. If master is target, target is equal to xy. Right. So make sure this works. 1, -1, which is probably right. I don't know. Yeah, 1, -1. Yeah, okay, fine. Okay, so now we have target, we have to start, so let's just do it, right? So we did depth first search, why not do breadth first? I guess we can't do breadth first search because of the minimum cost thing. Okay, so we just have to do Dijkstra. So yeah, so heap is equal to cost 0, 0, 0, and then distance is equal to right? Heap q dot heap pop h. We have d xy is equal to d. I know I'm reusing d properly. No, I'm okay actually. Right, and then if distance of xy is less than d, yeah. We break. Is there a -1? There is a -1. Okay. So then we can return -1 if x is equal, if xy is equal to target, then we return d. Otherwise we just do regular Dijkstra, right? So for dx dy y do in directions, and x and y is equal to x plus dx, y plus dy. If nx and y in cost and nx and y not in distance, then we set well, if it's not in distance we definitely do it, but okay, let's actually write it a little bit differently. If this or distance of nx and y is greater than d plus cost of nx and y, nx and y is equal to d plus cost of nx and y, and then we also push this to yeah, and I think that's it, maybe, hopefully. Let's give it a submit. Yeah, okay. I mean, the depth of search, oh whoops, I left in the print. The depth of search is going to be linear v plus y, where y is 4 times v, right? So the number of nodes. This is very standard depth of search stuff. Yeah, and this is Dijkstra. Also, was it like v log y or something like this, or v squared, or yeah, v log y for every yeah, something like that. V square log y? I don't know. I'm blanking out today. But yeah, but Dijkstra's algorithm, pretty standard. And yeah, that's what I have for this one. Let me know what you think. Kind of a little bit long though. Wasn't that bad. Kind of interesting possibly. But that's what I have for this one. Let me know what you think. Stay good. Stay healthy. Do good mental health. I'll see you later and take care. Bye bye.